Okay, let's look at the limit now as x approaches 0 from the right of sine x over x squared. And when we plug 0 in here, the sine of 0 is 0. The 0 squared is 0, so we've got this indeterminate form. And what that means is we're going to have to take some derivatives, okay? Not a big deal. We're going to set it up so that we've got f of x equals sine x. And we're going to set it up so that g of x is equal to x squared. Deriving the sine of x gets me cosine of x. Deriving g of x gets me 2x, okay? So take the derivative of the top, derivative of the bottom, and then we're going to put them right back into the limiting process here. And when we do that, here's what we're going to get. We're going to get the limit of x approaching 0 from the right of cosine x over 2x. Now, believe it or not, we can actually do this one because when you put 0 in for cosine, you get 1. When you put 0 in for 2x, you get 0. Now, this is an undefined term, so we now have to look at and investigate just a little bit about our graph and what's going on. So as we get close to 0 from the right, which means close to 0 from the positive side of the number line, then what you have is a positive number on the top, less than 1, and a really small positive number on the bottom, greater than 1. And what you're going to end up with then is, as you look at this limit now, if you take the 0 part out and just look at the limit, so what is the y coordinate doing as x gets really close to 0? What you're going to see is that we're going to go to positive infinity, because if we look at, like, say 0.0001, well, for the cosine part, the cosine of that is going to be a number that's really close to 1, okay? But if you do 2 times 0.0001, then that's going to be 0.0002. Well, 1 divided by 0.0002 is a pretty large number. So as we get closer to the x coordinate of 0, our graph increases and goes to infinity. Now, using these same tools that we did right here, we can also investigate the sine of x over x squared as x approaches 0 from the left. And it's the same process. If I put 0 in here, I get 0 over 0, which I cannot have. That's an indeterminate form, okay? So what I'm going to do is I'm going to actually look at the limit as x approaches 0 from the left of cosine x over 2x. All right, now plug your zeros in. Well, again, 0 gets me 1 over 0, which is undefined, okay? So there's obviously something going on at 0 that I can't use. However, if we investigate what's going on as we get close to 0 from the negative side of the number line, things change a little bit. So if I let x equal negative 0.001, when I substitute that guy into cosine, I get the cosine of negative 0.0001, which again is going to be close to 1, really close. When I put that same value in for x, negative 0.001, I get negative 0.0002. Well, large number on the top doesn't go past 1. It's below 1. Small number on the bottom, which means that when you multiply by its reciprocal, that's a big number. Well, I've got a positive divided by a negative. So in this case, that's going to take me to negative infinity. And if you're not sure what's going on, graph these guys. You can get a look at the graph on these guys and see exactly what's happening at the y, what y is doing as x approaches a specific number. Remember, with a limit, let's just have a real quick review. The limit as x approaches a of f of x. What we want to know is the y value we approach, okay, the y value we get close to as x gets close to a specific x value. So a limit we're looking for here is usually going to be a y value. All right?